want to take a quick look at fractions. We're going to go into our first calculus unit, and that is called limits. Limits depend on you knowing radii, and radii depends on you being able to work with a fraction. When we look at limits, you're going to see some fractions that look very similar to these. Is that scary? It's not scary. All you have to remember is this symbol right there means to divide. So instead of looking at that mess, we're just going to make it easy and say 1 over x plus 3/4 divided by 3 over x plus 1/2. Okay, any time that you have to do what's called a complex fraction, which means fractions over fractions, if you'll rewrite them this way, it's a lot easier. Now we need to simplify each side because they have addition. How do you simplify fractions when you add? You have to get a common denominator. So what do you get when you add 1x plus 3/4? Well, you get 4 plus 3x over 4x. Does everyone know how I got that so fast? Can you do that?
No.
Okay, so let's go back and look at that. What's the fastest way to add quickly? We're going to have a lot of little fractions like this. Well, you could do this, right? And then you get 4 over 4x plus 3x over 4x. So that's 3x plus 4 over 4x. But did you know there's an easier way for you to do these little tiny fractions? All you have to do is say 1 times 4 is 4. There's a plus sign. 3 times x is 3x. And then multiply those together. And we're done a lot faster. You could do that with your eyes. Isn't that nice? It works every time. So then you just put a subtraction sign. So let's look at this. What do you get when you add those? Well, you get 6 plus x over 2x. I want to be able to do it with my eyes. I don't want to have to get common denominators on little tiny fractions, right? That's just crazy.
Yeah, now we're doing that.
We do not divide, I'll tell you that. We change this to multiplication and you flip over the second guy. And now when you have a fraction, you can always cancel top to bottom. So what will happen with the 2x and the 4x? 2x goes into 2x once. 2x goes into 4x 2 times. So we have 4 plus 3x over 2 times 6 plus x. You're good. How did I do what? Because I had 2x and 4x. And if you have 2x over 4x, right? The x is 1/2. So this 2x canceled with that 4x. Remember, for fractions, we always cancel top with bottom. Doesn't matter where on the bottom and where on the top, we cancel top and bottom. And if we need to, I could do some more of those with you if it's still scary after we finish these few examples. I can make up more. Now, do I want to distribute that too?
Yes.
I don't.
Why?
Why?
Oh, you can just simplify it.
No, can't simplify unless you can divide everybody, but we're headed towards limits, which make us need radii. And what does this tell me on the bottom? It tells me where my asymptotes are. So if I change this into 12 plus 2x, my asymptote won't be as visible. So I like it factored for what we're doing. We are using this for radii. Okay. All right. What if they make it a little more complicated? This one would be what? 3 over x plus 4, x minus 4, plus 1 over x plus 4. Now, what do we do here? This one's a little bit harder. Not bad. Oh, I don't know why I did that because I was talking. That's a 3. Now, what's going on here? They both have a plus, so that's good. But the right side is missing a minus. So do I have to put one over there?
No.
Yes.
Yes.
And if I need that to be in the bottom, I'm going to have to also put it in the top. Yes. You can multiply by anything as long as you multiply the top and the bottom, because x minus 4 over x minus 4 is really 1. And you can multiply by 1 and you don't change something. So now we have 3, right? I'm going to write the whole thing out so you have all the steps in your notes. But yes, if this were a problem, you could probably do it with just your eyes. Now that we have a common denominator, we can combine our top, and 3 plus x minus 4 turns into what? X minus 1? Because 3 and negative 4 is negative 1. And we will be finished. This is nice. I want to leave it that way because I know I have an asymptote at negative 4 and 4. I know I have 2 asymptotes. And what do I know? What does the top tell me? Do you remember? What do I have at 1?
Axis of symmetry.
No. No. Do you remember? The x-intercept, right? We'll go back and review this. Okay. The other thing we need to be able to do is state the excluded values. What's an excluded value? What causes one of those? Right? What causes this guy to be in a problem? That's whatever makes bottom or denominator equal to 0. So whatever would create a 0 in the bottom is an excluded value. You know you can't have one of those. If you create one, we're going to get a black hole and we'll all get sucked in and be gone. You can't do that. All right. So how do you solve these problems? Number 1, factor. Number 2, state excluded values. And we must go in this order. And then we simplify. If you simplify before you state your excluded values, you're going to miss some because you're going to cancel them out. Okay, so we have to factor first, always. So this is what? P plus 4 over P plus 2, P plus 4, right? 4 times 2 is 8, 4 plus 2 is 6. So what can P not equal? Negative 2 or negative 4. Because if I plug those in, they will create a 0 in the bottom. We must never, ever do that. Now I can cancel. I must do this first because that's what's going to be excluded from your domain when we look at our rating. So now we're going to go, and what's left? 1 over P plus 2. Once you cancel, this will be the thing that you're going to work with in your calculus to answer questions. We don't have to deal with the guy we got rid of, but we have to identify that we got rid of him, right? All right, let's look at the next one. What can you factor out of 15a and 15? Yes. That leaves a minus 1. What can a not be? 1. Now, can you simplify? Will anything divide out from 9 and 15? 3. So we're going to divide out a 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Right? And we're done. This tells us that we have an asymptote at 1. Well, let me ask you this to foreshadow your future. Is there an x-intercept in this problem? Is there? Is there an x-intercept?
Yeah.
Can you set the top equal to 0? Is there a variable?
No.
Is there an x-intercept?
No.
No. And that's really handy to just recognize that and know. Just getting you ready for your future. All right. This one. What can we factor out?
2.
2a. And what is left? A plus 5. What can we factor out of the bottom? Okay, what can A not equal? -5 or 0. If you've got 3a here, if you plug a 0 in, that's going to create a 0. Okay, now will anything cancel? Well, a lot of stuff, right? Now, what about this A with this A? So what's left? 2/3. That's all we got.
Let me do the next one.
Y'all try the next one.
No.
I'll give you time. Now you try one. Okay. So when we look at that, we see, and there's our final answer. You're ready to begin your work.